Hello everyone, Mr. Stevens here again with another lesson on, this time, appreciation and inflation. These are two words to describe the way the cost of things or the value of things can increase over time. And actually, what we're going to be doing is simply applying the compound interest formula to both of these scenarios. So firstly, what is it? You don't really need to write all of this down, but if you could summarize it in some way, this first sentence here is one of the most important parts. It's the increase in value of items over time. And it goes into an example here. A painting, for example, worth $100,000, appreciates at 10% per year. After 1 year, it's worth $110,000. And then the next year, we recalculate the appreciation based on that total amount. Same way we would do compound interest. Inflation is basically the cost of things goes up. Your money becomes worth a bit less. And it's usually also given as a percentage, so we can apply the compound interest formula here again. So let's just practice it. We should be really good at doing this by now. The first thing we're going to do is write down the compound interest formula, just in case we've forgotten it. And then we're going to apply the numbers from this question. Even though it's an appreciation question, everything fits into this formula. The same way we've been using it for compound interest. Put it in 9% as a decimal, and it's appreciating for 7 years. So if we put that into our calculator, it goes to $1,261,346.99. And it tells us to answer to the nearest dollar, so the unit is worth, I can't write properly, 1261347. We've rounded up there to the nearest dollar. Okay, inflation. Same thing again. We're going to use the compound interest formula. And the numbers we're going to feed that formula are here. We've got $650. We've got a rate of 2.6%, and it's going to be 1 year in this first one. So in the first one, after 1 year, the dryer is worth, if we put that into our calculator, $666.90. Same thing again in part B. Still always using the compound interest formula. This time the numbers that we're putting into the formula are here. And 3 years. So if that one goes into our calculator, it comes out at $439.64. Alright, so you guys should be pretty good at using the compound interest formula by now. This is just a little bit of extra practice for you, so I'll get you to jump on exercise 3F and do questions 1 to 7 for me. Thanks, guys.